Hello, this is Maria from mathmammoth.com. In this lesson, we are going to review some angle relationships and concepts from 7th grade. First of all, what is an angle? In mathematics, an angle always consists of a vertex, one point, and then out of that go two rays. There, two rays sharing the same starting point. That's an angle. You've learned about acute and obtuse and right angles, reflex angles, straight angles. Let's review those two. An acute angle is like this. Kind of feels like a sharp point here. It's less than a right angle, less than 90 degrees. Okay, so what's a right angle? Like that. And here was the acute angle, this one here. Obtuse angle is more than 90 degrees, so it's opened up a whole lot more, kind of like that, for example. It's more than 90, but it is less than 180 degrees, which if you have a 180 degree angle, it looks like a straight line. The vertex of the angle is right there, and these two rays go in opposite directions. So over here is then 180 degrees, a straight angle. And then if you go more than 180 degrees, you would have a vertex, then one ray going this way, and the other ray, it goes that way. But we look at this angle, then that's a reflex angle. Okay, more than 180 degrees. Next, what are adjacent angles? Adjacent angles are two angles that share the same vertex and also share one side, or one of those rays is the same. So let's say here's a vertex, and one angle is like this, and then the other one has to share the vertex and share one of the sides too. Then it has its other side somewhere there. So we have one angle here, and the other one, this one here. So those are adjacent angles, or neighboring angles, or side-by-side angles. All right, some more angle terminology. Complementary angles and supplementary angles. Those are sometimes hard to remember and distinguish between, but this is how I remember them. Complementary angles form a corner, and supplementary angles form a straight line. There's the C and C, S and S. So there's a certain corner that I'm thinking about when it comes to complementary angles, and that is right angle. This is my corner, and complementary angles, two of them, form together a right angle. So I could have, for example, this one angle, and then this one here is the other one. Together they form a right angle, or corner, so to speak, so they're complementary. However, complementary angles do not have to be adjacent. They don't have to be side by side like that. They could be, for example, let's say one of them is here, almost a right angle already, then the other one is over there, really small angle. So if those two together make up 90 degrees, then they are still called complementary angles. And the same is true of the supplementary angles. They can be adjacent, but they don't have to be. Supplementary angles, one common example is that if we have a straight angle here, then we have two angles that form it. Here's one, and then over here is the other one, an obtuse angle. Those two together are supplementary angles. But they don't have to be adjacent. Let's look at another example. And that's just a plain old parallelogram. And that is because in a parallelogram, this angle here is congruent to the angle at the opposite corner. And then this angle here is congruent to this one here. But altogether, these four angles make 360 degrees, which means that this and this make 180 degrees. So we have this angle here and this angle here. They are supplementary angles because they add up to 180 degrees. Okay, one more term, and that is vertical angles. We have two lines that intersect. Then we have two pairs of vertical angles here. This angle and this angle are called vertical angles, and they are congruent, in other words, equal. But also, this angle and this angle are vertical angles, and they are congruent too. All right, let's now solve an angle exercise. Angles AOB and BOC are complementary. Find the value of x. So what do we learn by knowing that those two angles are complementary? Complementary meant was the corner, the right angle corner. So those two angles make a right angle, 90 degrees. And A or B is this one here. That added to BOC, which is 46, is 90. So we can write an equation, right? A or B in itself consists of two angles. There's x and 3x. They are adjacent here. So we get x plus 3x plus 46 equals the right angle, 90. Now we can solve this equation. Here there's x and 3x. We can combine those to get 4x. Then we subtract 46, leaving 4x here. And over here is then 44 degrees. And now it's easy to see that x equals 11 degrees. This angle here is 11 degrees. This angle would be 33. Our last exercise for this lesson. Think about it. Can you solve it? There's two lines. It says that line L and line M meet at this point. And find the angle measures x and y. Okay, the reason we need to know that these two lines actually meet here, point O, is that when you have two lines intersecting, you get vertical angles. Vertical angles are congruent, and that will help us a lot. This angle is 106 degrees. It's here, L and M, and it's somewhere else too, right? Because we have L and M intersecting, forming vertical angles. Follow L this way, M this way, so this one here is also 106. So that solves x basically, because now we know that x and 34 together make 106. That means that x is then 72 degrees. How would you solve for y? Y and the 106 angle together form a straight line, right? So we have y and 106 forms a straight angle. And from that, then, y equals 74 degrees. All right, did you get the same? I hope so. We're all done with this. I hope it was helpful.